be talking about robot landscape. We use two motors for moving the robot connected to ports C and D of the hub. Two motors for following missions connected to ports A and B of the hub, and light sensors connected to ports E and F. We researched and used the ideas of Droidbot Model E from a website.
Our robot features include symmetrical design, common attachment interface for easy connections, dual front motors for simultaneous mission execution, larger wheels with protected beams, and then we have ball bearings for smoother movement, and pins to secure port wires neatly.
I'll be talking about game strategies. So we use jigs to help with accurate launches. We also started with the side that required more setup time and had more obstacles to face. We also made sure that the robot only went through a path once and always used the shortest route around the field map.
We use the gyro sensor for accurate turns and the light sensor as calibration midway for the run. To reduce robot time in the home area, we plan to accomplish more missions in one run. To do that, we use the same attachment for multiple missions. We continuously refine the robot design and the attachments while working on the missions.
I'll be talking about attachments. We built 3 attachment interfaces to support 5 different attachments and a few passive attachments. These attachments will be used for the blue side of the launch area.
So this is the Run One lifter, which is used to self-changing shipping lanes and seaplankton. This is the shield, which is used to grab and safely carry the sea creatures across the board to the other launch area. And then these attachments are going to be used for the red side of the launch area. So this is the scuba diver arm, which is used to solve the scuba diver mission. This is the multi-purpose arm used to solve shark and raise the mast. And this is the passive attachment we're using to solve coral nursery. I don't think we have the third attachment interface.
We were thinking of implementing this, but we didn't have enough time to code or add this to our project.
Yeah, this was going to be used for the research.
Robot design. Yeah. Challenges? Okay. I'm going to be talking about the code. We utilized the Legos Pipe Prime word box and organized our code with comments, functions, and process blocks. One of the functions we created is called initial setup. In this function, we set the movement motors, we specify the motor's action when it stops, and we provide the speed as the input. We also use the gyro sensors that are built into the hub. This reads the yaw angle for accurate turns. We also used color sensors to calibrate the robot's position halfway through the run.
We are doing 2 runs on the blue side of the launch area, and then the rest of them on the red side of the launch area. For run 1, we start off with the unexpected encounter, changing shipping lanes, and then collect the sea plankton. For run 2, we do the semi-weather submersible, collect the seabed sample, then we do anglerfish fish, we collect the water samples, and then we collect the sea corals to the rest of the launch area.
For the red side, we saw part of coral nursery, pick up the scuba diver, complete shark and coral reef. Then in the next run, we saw raise the mast, we dropped the samples collected, place a shark in its habitat, and finally we saw artificial habitat.
I will be talking about challenges. Over the past 6 months, our team has faced a lot of challenges, including the missions Coral Nursery and Raise the Mast. Designing a multi-use attachment for both missions was quite difficult and took us a long time to get right. Another challenge was the fact that a lot of our team is new to FLL this year, and there was quite a steep learning curve at the beginning of the year. However, we were able to utilize the experienced FLL members' knowledge to help guide our team along. After the qualifiers, we had some trouble with our code, including the code producing inconsistent results, forgetting our alignments, which caused a major setback. Overall, we think we did well and stayed united while sharing our talents and thoughts. Thank you, judges. Do you have any questions?
That's great. So like with the different missions out there on the table, was there a process for how you decided which ones in which order?
So
or which ones not even do them?
Yeah, we first planned out what missions we'll do and for like what attachments we'll have to create, or like what attachments we'd have to create to solve those missions. and then we'll just like plan out, okay, we'll do this first, then this, and then we'll make like a map, which is shown right here, and
And adding
we'll
on
just
to
follow that.
what Carney said, we started off with the missions that were closest to the launch area, and then after that we gradually went up.
So I heard you say you were using the color sensor to calibrate as you're moving through the board.
Yeah,
What are you
that's
actually doing with that?
midway, so right, next to, the scuba diver, right here, you'll use it as a way to, like, if something happens, like, or, the robot, moves to a different direction, it'll recalibrate, and it'll align to, like, this line right here, so that it could push in, the scuba diver correctly.
So you use it to kind of straighten up when you're on the board. Interesting. That's very cool. So then, okay, let's see, yeah, so what resources did you use to kind of, learn more, kind of, how'd you, what resources did you use?
So we
to
use
go inside?
fltutorials.com for the robot, and we got ideas from like YouTube videos on like how gears work, because some of these people are first time learners, so we just taught them how everything works. And we also used like we resourced a book too, and we looked off a website called Droidbot Model E website, which is where we got the robot design.
How many, I guess, what's your maximum points you see right now, and how often, what's your typical score on, like, if you did it 10 times, 10 rounds?
So our typical score for a robot is 250, but we're trying to target like 300 points. So,
That was our goal.
And I heard there's another attachment you're still working on. Is that something that you still have kind of timed in the 2.5 minutes where you see
We
some ability to
haven't-
incorporate it?
We haven't coded out the robot to use that attachment and do the mission. So, because we were really close on time, and we were trying to perfect our other missions that we had with our attachments, we tried to put this one in, but we didn't have the exact amount of time to incorporate it.
this attachment was for the research vessel mission, so it was to push the boat across and get it across that yellow part, and then you want to show how it works.
Yeah, so there would be like something here that like turns that gear, which in turn pushes this gear rack in, which pushes out the scissor lift.
So,
And these hold up the scissor lift, so it doesn't bend over
so
when it's
the way
on.
how we started off with this attachment was one of our teammates were just playing with beams, and they just used pins and beams, and then they just crossed the beams together, and then we sort of got this idea of doing it.
That's a good job explaining and tracking there. So I saw some of your attachments that look like maybe you have multiple actions off the same attachment. Is that,
Yes,
so you
so
have like one attachment base and multiple motors off that attachment base?
Yeah. So, for example, this is a multi-use attachment, and it solves shark by having like this big thing like smack down on the shark thing,
Yeah.
and then it has this little thing to raise the like other thing.
Raise the max.
Raise,
Yeah.
yeah.
And so that's what, so then from when you attach that on there, then as it goes out, you can have two different kind of motor movements, because you have two different motors off the same kind of attachment base there.
and then we have dual front motors that go with our attachments. So we want to just save time, and we want to be efficient. So
So it slides right in?
Yeah.
We can
Yeah.
do a demo.
Did you guys come up with that, or is that something you
so
said elsewhere?
So we came up with the attachment idea, but the robot, and we actually kind of used our idea and the website. We combined it together and then we came up with this.
Yeah.
So it's really easy to fit in. You just
Yeah.
plop it in,
Put it in
and then
and-
there's this pin right here. You just click that, and then
We put the pin in so it can be secure, so when it runs, so it doesn't like mess up or fall off.
And if you look on the back, there's two gears which connect to these gears here, which like rotates this thing up and down.
yeah. Some challenges we faced with building the robot was tucking in the wires. I think that was the most annoying part ever. So that's why we used pins to tuck the wires in, and we try to make it look like this. Yeah.
So we are moving into that final portion. So do we have any other questions